I'm Vice President of Business Development and Operations, and so I get to choose where I go these days. So this is a favorite of ours. We were founded in 1986, initially doing bathymetric surveying, developing platforms, single beam sonar at that time. In 1997, we began development of the virtual remotely operated vehicle system, a PC-based networked solution for ROV simulation. The first simulators we released in 1999. First simulators were sold Oceaneering at that time. That was a nice day when that happened. I need my glasses. So it was initially a training tool for novice pilots, but over time, as the fidelity developed and the capabilities improved, we were able to use it for more and more real-life related applications, among them mission planning rehearsal of actual subsea tooling and subsea field installation, this sort of thing, supporting engineering design of oil fields, providing a tool to do layouts of infrastructure, dams or ports, sort of thing. We've added the capability of, we're the only ones who do high fidelity multi-beam sonar simulation. Multiple ROV missions. It's the only product that can handle substantial complex missions with two ROVs operating in the same environment. And we've done several leading in the area of integrated training, so we can tie into or provide our own ship's bridge simulation, crane, and ROV simulation, all in the same situation. So instead of just someone learning how to use their particular piece of kit, they learn how to operate as a team and advance the capabilities of the team in that way. So a few years ago, we undertook a major redo of our physics, and we're looking for applications that demonstrate it in some of the new technologies. And through a Canadian government program, Built in Canada Innovation Program, we're accepted because we've had a range of innovations in it. Coincidentally, the Royal Canadian Navy were seeking the ability to train their ROV pilots with navies. Navies don't have the luxury that the Port of Long Beach has, where they can maintain their trained and qualified people in the same positions, doing the same jobs over many years. A lot of times they're switching in and out. So people need to become proficient quickly, because what they have to do is the requirement is immediate and extremely important. The Fleet Diving Unit, for example, where we delivered these systems, did the Swissair recovery, and that was before they had the benefit of a lot of actual in-water training and simulation training. So it's a critical skill that they must have, and a critical capability Navy needs, but they don't have the ability to do long-term training for everybody. So they need to be able to learn how to use the tools. That includes interacting with the control software, but also good piloting techniques, how to operate sonars, the tooling, manipulators, this sort of thing. So there's a lot to learn in a short time for these people. They needed realism in the scenarios and the pilot conditions. So it had to be scenarios that they were going to be using offshore. So we conducted a lot of discussion on what type of emissions they wanted to see. They wanted to be able to do objective measurements of the capabilities that people were developing. So to be able to do a baseline for everyone, and then measure how more proficient they became in doing these tasks, and was mainly measured in the simulator because they jumped in and started measuring, training before they did any baselines in real life. And they needed training without continued presence of an experienced pilot standing over them at all time, which basically doubles the resources that you need to do training. So they need to be able to do it individually. They need to do the proper training correctly. So they needed something to guide them in the software on what they need to do and in what order and how to go about it. And they had scarce resources in ship time, in ROVs, in subsea assets to train on, and they didn't want to use water in the training to the limit, so they wanted to do a dry land thing. So the simulation offered the ability to do a lot of ROV training without getting their socks wet. So the system setup, it operates just on a PC, very minimal. They use the hand control unit that they had with the real-life LBV systems that they have. And we delivered 6 systems to them in December 2015. 2 on the Pacific coast, Fleet Diving Unit Pacific, Fleet Diving Unit Atlantic and Halifax, and 2 in central Canada. So it's fully integrated with the Tritech control software, Pro module control software. It had 2 Tritech, a multibeam and a forward-looking. And all of the interactivity was exactly the same. It actually used the same program as for interacting as the actual ROV. We're now conducting an integration with Green Sea's system so that soon it'll be integrated on all the systems that are released for in that format. So the Teledyne BlueView sonar is one. There's a very clean image. There's complete control of gain and noise and this sort of thing. It's one we've provided. Subsea 7 used it, for example. It's actually integrated with their SeaBotix control system, so they're able to run simulations of missions, and the quality of the output, it's in the exact same format and same quality as the BlueView product would deliver to the autonomous system. So it can actually be used to train on autonomous systems, and to when they make changes to their control system, they can actually use the simulator to test whether the changes are going to work in the real-life system. So that's another way that it, and with the BlueView, you can tell that's a bike. That's definitely not a boulder. Up in the corner there, you can see a white script, and above a yellow script. That's the current objective and the next objective. So the person can sit down without having someone having to stand over them the whole time and train them. They know what they need to do because they're told there. It also keeps a record of every mission that they fly, so that you can identify whether someone's doing any work, and they're not just sitting at the ROV at the simulator. You can actually tell what they've done. You can see a big list of sort of 1, 2, 3, 4 down there. That's a list of all the objectives and how long it took to do each one. We've also got so that tells what they did and whether they were successful, and it also identifies gaps where you may find it's taken someone forever to locate a target. So you can say we need extra sonar training on it, and we have special sonar missions that they just get 6 hours of going through the sonar training, and they try to measure improvements in their capabilities in that. Also missions for manipulator interaction as well. So the missions that they identified: ship hull and infrastructure security, so piling and dam inspection, ship hull inspection, mine countermeasures, locating targets and going over and visually identifying them after the sonar has seen them. Search and rescue, or search and recovery, so it's actual body recovery in some of the systems with aircraft recovery of black boxes and that sort of thing. Evidence collection, that was in there. when that person was looking for a bike, there was actually machine guns and everything else in the water, so they're supposed to come back with a machine gun, not a bicycle. And there's a range of things. Our bread and butter had been oil and gas, so we've had a lot of effort in that over time, and we've done a lot on how to get skills developed in doing missions that are relevant to oil and gas people. So there was areas in some of the oil and gas stuff, though, even though it's not a Navy application, it's the skills that they were trying to develop, so they use some of those as well. So this is some, basically that's a target. So the systems have the hull crawler, which operates with the sonars, and so they have to learn the skill of rotating the vehicle and sticking to the hull, where I think I'm the only one in the company who can't do it. But it's not an easy skill to acquire and maintain, and if I were going to go out and try to do a hull inspection, I'd want to spend some time on the simulator first, practice it a bit, and then when I go, that just makes the time in the water that much more efficient. So so what we're seeing here in all this is actual simulator output. Anytime you can see the ROV, you're looking at the instructor's view. Anything like, so this is the instructor's view. Anytime you would also see, you would see any objects, it would tend to be, one thing that they discovered the Erebus was part of the Franklin expedition, and they wanted something to practice on, so because when they went in and looked at it, they didn't want to destroy, because you go in and start flying around and then you're cracking everything off and this sort of thing. So on this particular one, we put the Holy Grail in there, actually, to give them something interesting to find. But anytime any contact was made, it was measured, because they wanted no contact with any of the archaeological structure. And we also gave them missions for rescuing an ROV. It's a dual mission, 2 ROVs, one's trapped with a piece. So one has to wrap a cable around and then lift up a piece of the wreck, and then in order to rescue the ROV. So the dual mission capability was important. This one here is to locate the what's that called? We call it a black box. And in all these systems, the location of the targets is randomized, so they can run it 100 times and they'll get a different. It's not something you do it once and you know the monster is behind the door every time. It's everything's in a different place, so it maintains the interest in there. So they're all just as challenging. So multiple ROVs implemented, mine countermeasures, pod posting, sub rescue, ROV rescue, like I mentioned. There's a mission design kit in it. Down the right you see a lot of mines or mine-like objects, odds and ends. The bike is in there. And just a range of things that they can populate a piece of terrain with and then do their own mission. They can also set it up, go in like that wharf that we just saw. They can go in, tie it up, save it, and then give it to their partner and say, all right, get your ROV out of that. So this system is something whereby you might put in the bathymetry for a port and the infrastructure and the piles and this sort of thing, and you could maintain a record of the infrastructure you're interested in. These are the actual pilots. They're using 2 systems. I think it's in in the fleet diving unit. Feedback we've got, they work great for us. They're more than happy using it as part of their training program. We had 1 support call in 2 years, and that was in the first week, and it was a guy who said, I wasn't at the 4-hour training session. How do I set it up? So anyway, we directed them to the page in the manual, plus we walked through it for 5 minutes, but it ruined our perfect record. So it's something, they're quite capable people, and but I think he was just really eager to get using it. So out of the debriefing after that period, team training enhancements was something they identified as valuable. They were gaining the skills to do the jobs that they need to do, but there's still the working together and the complications that team training requires. So we had been developing a common operating picture for well response, which can deal with up to maybe 12 ships, 6 work-class ROVs all operating at once, maybe some couple clearing debris, some putting a cap on a capping stack to cap the well flow, installing risers, flow lines, or various things like that. And these things are big, complex, critical operations that everybody has to know what they're doing. You can't have ships just coming back and forth, in and out, and having everything tied up in a mess. So as we were going along, and that's quite challenging, we're still working on it, but we realized in the course of it that we had developed the capability to have 6 or 7 ships and 3 or 4 ROVs, which is not quite what we're shooting for well response, but it is something that can handle the mine countermeasures typically. So we have here some of our highly trained and enthusiastic individuals. This common operating picture features 6 controllable surface vessels, 2 Teledyne SeaBotix LBVs, a work-class ROV is a shilling, and 1 AUV, it's an ISE, and 2 launch and recovery systems. So it's extremely complex in terms of simulation, and it was all operated on 1 laptop. So right there, there's 5 surface ships, or 4 surface ships, and I think a helicopter there. He's dropping in a sonar system, and actually when it hits, I love this, little splash. This is a launch and recovery, Hobbolt launch and recovery system for the ISE vehicle. And again, this is actual simulator output. We just put it together we just edited it. Again, this is the instructor's view and the mine there. They like to film the demonstration stuff under very clear water. This is the instructor's view as well. The work-class ROV has actually got to undo the submarine hatch and then put a resupply pod in it. This LBV is discovered there's a hull's been penetrated, so they have to resupply the sub and search for other mines as part of this scenario. So I think that's all I had to say.
Teledyne Marine. Everywhere you look.